Okay, we're still looking at characteristics of functions, but now we're going to look at solving a real-life problem. All right, example 3. Researchers send 2 robots to explore an asteroid. The robots move by hopping between locations. The graph shows the path of robot A's first hop. Robot B lands 60 feet from where it starts its first hop, reaching a maximum height of 48 feet after traveling a horizontal distance of 30 feet. Compare the 2 hops. All right, so to get started, what we need to do is probably first let's graph robot B's hop. Robot A, we can see that it's already graphed here, but it gives us information so that we can graph robot B. So if we want to compare the 2 hops, we need to have 2 of the same format. So we have a graph and a verbal description, but let's take the verbal description and also graph it. So it says robot B lands 60 feet from where it starts its first hop. Okay, so we know it's going to land at 60 feet here. It reaches a maximum height of 48 feet after traveling 30 feet. So if we come over to 30 and go up to 48, we know that's going to be its maximum height. And if we start at 0, 0, then we can sketch that graph here that looks like that. So I'm going to pause the video and get a graph sketched. Okay, so now we have the graph of robot A and we have the graph of robot B. So now we can compare those because we have a visual image of both. All right, so if we go back and look at the initial question, it says to compare the 2 hops. So if we're looking at the graph and we're trying to compare the 2 hops, we can look at things that we've learned previously in this lesson. We can see that both of them have parts of the graph are increasing and both of them have parts of the graph that are decreasing. We can see that the maximum height for robot A is greater than robot B, and we could kind of estimate on what the difference of those maximum values would be. We also can see that robot A travels about 45 feet from its initial hop, so it goes from 0 to about 45 feet, and we can see that robot B doesn't go as high, but it lands about 60 feet out. So it goes about 15 feet further horizontally than robot A. So if we kind of estimate the height here, this would be 40, 50, 60. This one's probably about, I don't know, 50, 55 maybe, 56. And this one, it gave us the maximum height there of 48. So let's say we go from 48 to 56. That's a difference of about 8. So robot A goes about 8 feet higher than robot B. Okay, again, that's just an estimate. We don't know exactly what that is because robot A, we're only given the graph here, so we don't know that exact point there. But that's a way to compare your 2 graphs. And you can always compare the intercepts. Okay, they both have an intercept at 0, 0. Robot A has an x-intercept at, it would be 45 and 0. And robot B would be 60 and 0. And of course, the y-intercept would be the initial start value. So it'd be the same for both of those. And then, of course, the maximum height is going to be where it goes from increasing to decreasing. So when it changes direction, so it's going to be increasing up to the maximum height, and then it would be decreasing, and that would work for both of those graphs as well. All right, so solving real-world problems and being able to compare the hops, most importantly, was to have them both graphed so you could visually see what was going on, and then it kind of makes it easier to compare. All right, if you have any questions, please let me know. I know I kind of talk fast, so here is the solution written out if you want to put this in your notes. would be good if you need to go back and reference for an example later when you're working on your homework. But hopefully this is a good example of a real life problem and how you can use the graphs to compare two functions easily. All right.